Welcome to another episode of Software Explorations, Concepts and Overviews, hosted by yours truly, Tech Coach Ralph, where we are engineered to win. In today's episode, we are going to continue going through our overview of API testing. Today, we're going to be focusing on how to automate API testing. Last week, we spoke about getting into API testing, and the week before that, an overview of APIs. If you haven't seen any of those, I would highly recommend that you jump into those as it will continue helping you get a better understanding of APIs altogether, testing them in a manual way, and today in an automated way. All right. So let's jump right into it for today and get into our API testing through automation. We're going to be talking about, like I said, automating API testing. How do we automate API testing? So, our agenda, we're going to have a recap of the past 2 weeks, an overview of APIs, as well as an overview of doing like API testing, the general overview, as well as doing it manually. Then we're going to talk about the manual testing challenges of APIs, how automating API testing benefits us, the tools and frameworks to be used, and we're going to dig deep into those a little bit more, some best practices for API testing, and then we're going to review some case studies, some challenges that come about with automating API testing, and then we're going to wrap it up for today. All right, so let's go. So, recap of APIs. API stands for Application Programming Interface. APIs allow integration, efficiency, and innovation. APIs provide access to a vast amount of data from various sources. The types of APIs that there are, just name a few. There's RESTful APIs, SOAP APIs, GraphQL APIs. We spoke about the components of APIs, and we did some examples with Postman and some case studies of APIs. So that was our recap. If you haven't seen that video, I would highly recommend you go and check that out. Very, very informative. Now, last week, we went into a recap of, now we're going to be talking about a recap of API testing. Last week, we spoke about the benefits of API testing, how they're very useful, how to prepare to test the APIs. We spoke about what API testing environments are, how to review the documentation, why they're so important. We spoke about endpoints and methods. We spoke about generating test data for API testing, the technology used for APIs, and API testing tools. So we reviewed all of that. If you haven't seen that video, I would highly recommend you go back and check that one as well, as there is such useful information, and it's going to build into this episode for API testing in an automated way, because everything builds, like, you need to know what APIs are in order to be able to test them. And then in order to be able to automate them, you need to know how to test them so you can automate that process. So what are some of the cons? What are some of the drawbacks of manually testing APIs? Which there are a few, but let's start off. So it's very, very time consuming. Anything that you have to do manually is going to be very, very time consuming. It's human. It's prone to human error. And what does that mean? Because we have to, like, when you have to do things manually, that means you have to go do the same thing over and over and over again. But there's always going to be some slight variation in it, which can cause the results to differ. So we're supposed to put a 2 and we put a 1. How many times in coding when we're supposed to put a semicolon and we don't put it and the whole application doesn't work? So manual testing of anything, but specifically APIs, can be very error prone. There's limited test coverage that you can do with manual testing of APIs, because there's only so much you can do. There can be thousands and thousands of variations of the different positive and negative tests that you're sending, but a human can only do so much. And if you have to do that on a regular basis, it's going to be impossible to get it done. The next thing, the reason that a big con for manual testing, it's super, super repetitive. You have to do the same things over and over and over and over again, when you can take the time to automate it, to write the code for it once, and then run it as many times as you want. And now you're avoiding having to do those repetitive tasks, and now you can be more efficient. It's also not very scalable, because trying to grow it, running it in different environments, doing all these different things in a manual fashion, it's just about impossible. Human availability. At my company and at many companies that I've been at, we would run our API test overnight. And any type of test would be running overnight, because some tests take longer than others. API tests can be pretty fast. So it's able to work when humans aren't available. When humans aren't available, we're not doing any manual testing, and you can only do it so much. It's also very resource intensive, because you need to have an actual human person doing the same thing over and over. We talk about the repetitive task. And then you're having like all these computers, all these tools, all this data. Where if you have it automated on a system, it can just go and go and go, and you can run it in many different environments, many different times. Another thing is repeatability. It is so hard to repeat the same exact test over and over and over again, even if you're following a test case, because like, with the prone to human error, there's going to be slight variations in the work that we do, things like that. So we need to find some type of schedule where it can be repeated, even if it's repeating at the same time. You can change the time. With the API tests that I run, I can run them whenever I need to, and they're also running on a schedule, right? So as we make a change, we can say, okay, let's run all the API tests. We get fast, immediate feedback. The next thing is there's no real world simulation with manual testing. And the fact that we're able to deploy our API tests and you can just pass a URL, run this API test in this URL, run it on this branch, run it locally, run it in staging, run it in production, anything like that, it makes it a lot more feasible to simulate what's happening in the real world. And then lastly, there is no pipeline support for manual testing. And what does that mean? So the pipeline, CI/CD, continuous integration, continuous deployment, continuous delivery. When you push up a branch, or you can like it can automatically execute and do a test for you right then and there. It can execute your unit test, it can execute your UI test, it can execute your API test, whatever type of test you have that's automated. It will be triggered in the pipeline, and then you get fast, immediate feedback. So you're not randomly guessing, oh, is it safe to merge this or not, right? So that is one of the huge advantages of doing it an automated way, and a major con for the like manual testing. And it's all about the pipeline nowadays, going through GitHub and everything like that. So this is a major red flag, because you cannot have a human in a pipeline. It's just going to cause clutter, and then the plumbing gets backed up, and it's gonna be a total mess. All right. Now let's talk about some of the benefits of API automation, which we we kind of touched on in the cons of manual, but let's focus on automation now. So with API testing automation, there is much faster test coverage. And what does that mean by test coverage, right? So as I was saying, there like with the amount of variation between negative tests and positive tests, you can have so many, like you can have thousands of tests that run in minutes, sometimes even seconds, right? And you're getting immediate feedback right away. So compared to if you have to run 10 tests, 10 API tests manually, you're looking at maybe 30 minutes to, like, if it's 20 tests, 30 tests, hours on a day, like pretty much wasting time. So you get such immediate feedback because API tests run so much faster than UI tests. So you get immediate feedback to know exactly if something's not working. If a developer made a change, you're in your test, and you can see right away. And even so, developers as well can run the test. So you can write a API automated test, and now you can say, hey developers, whenever you make a change, run this regression test so you can have immediate feedback if something broke, and then they can check it. And before they even send it to you to say, hey, this is done, they can find out if they broke anything, and they can go ahead and fix it right away. Now we're preventing multiple people's time being wasted because we have the tools in place to let us know right away if something broke, and it gets done immediately. We don't have to wait minutes upon minutes, or not even minutes and hours to get some feedback. The developers can know right away, and we can get that resolved. And then once that's fixed, and they can say, hey, we made these changes, it's working. Can you take a look at these new things that we added? And we don't have to go back and focus on the old things because we have immediate feedback to the developers, which leads us directly into improved test coverage. The fact that we can have thousands of tests, that means that we're fortifying our code and our software so much more, because like I said, a human can only test so much and so much and so much amount of time. If a human had unlimited time, they could test everything. But then as soon as the developer makes a change, we need to test everything again, which makes it inefficient. So the amount of test coverage that gets improved with API automation, and what I've done in the past, I've used spreadsheets that have lists of data, and then the automated test just goes through each row, passing in a variation of test data, giving you immediate feedback. So there might be nothing wrong with the first 100 scenarios, but then let's say it gets to the 500th scenario and it fails. We can immediately go and look, why did it fail? And is there a defect here? Do we need to fix it? which leads exactly to early defect detection. So the same way that I was mentioning with the faster test coverage, that the developers can run the test themselves and they can find out if they can see if they made a mistake, if they made some type of error in development, and they can fix that right away. Now with our improved test coverage, where we can have so many different variations of tests that all of them have to work, we can find out immediately within seconds, within minutes. We can find out, oh, the developers made this change, and in the 500th variation, we found an error within seconds, and now we can get that fixed. And now our software is safe. We don't have to put risk out to our customers, because sometimes like a defect can live in production because the customers don't really interact with it, but it can come to that point where the customer ends up interacting with it, and then we have hell to pay. Right now, one of my favorite parts: reusability of test scripts. The tests that I've written in the past, whether it's UI tests or API tests, I can't even count the amount of times they get run. It has to be like in the thousands of times, because not only do they run daily, we also run them on demand. So we make a change, we run the test. We make a change, we run the test. We push a branch up, the branch automatically gets triggered to run the test, and we find out immediately, and we're able to use the same exact test over and over and over and over again, and then we continue to add new. So instead of a human manually writing these new tests, we have our robot to go and to run the test, and then we can focus on the newer stuff and doing like and seeing if what was done broke anything, and we can focus on that instead of like just doing repetitive tasks over and over and over again. Automated testing is the new outsourcing. So when they used to send jobs overseas and stuff like that, now because of automated tests, we can focus on the things that are important, while and that are useful, while our automated tests are finding if there's anything that's breaking, and we can go off that. And then another benefit is the CI/CD pipeline integration, which we mentioned in the cons of manual testing. The CI/CD pipeline integration is where you are plugging in your tests into a deployment and development pipeline. So when the developers push it up, it automatically triggers our unit tests, our API tests, our UI tests, all of those things, and we're able to get that immediate feedback. And we can have it so if a test fails, it can prevent the branch from even being allowed to merge. All right. So, what are some tools and frameworks that we use for automated API testing? So, is so you'll see some of the tools that we use for manual testing, but they have some features that can allow automate testing as well. So we have Postman, we have SOAP UI, we have Rest Assured, we have the request library from Python. There's Karate DSL, which works on Java. There's Apache JMeter, and then there's Swagger. We touched on a few of these already, but we're going to go in depth a little bit more about how they're used for automated API testing. So with Postman, so here we're just going to give a basic rundown of what you would do to get started with API testing in Postman, and we're going to do that for the other tools as well. So for Postman, you would be creating an API collection, you'd be writing test scripts, you'd be running the collection, then you'd be launching the test using Newman, which is a CLI, command line interface, where you can say, okay, I need to run this collection. And when you would have to manually go into Postman and choose the collection and things like that, Newman is going to say, okay, I'm going to run this whole collection and give feedback from there. And then you can integrate running Postman scripts through Newman using the CI/CD pipeline integration. And then you'd set up like your test data, so you can have variations of data and not just like one static thing. And you do that through passing variables, and then you'd be monitoring and reporting the results on those tests. And you're going to see that all of these tools, they follow pretty much the same flow. It's just the way that you do it using those tools would be different. Right? So SOAP UI, very similar, creating test suites and test cases, adding the test steps that need to be followed, defining the test data and the properties. So that includes like your environments, that includes your endpoints, that includes your variables, your authentication information. All those things need to be defined in the test data and the properties. Then we're going to be writing our assertions to say, okay, when I send this request, this is the expected response that I should get, including the status codes, including the request body, everything like that. And in SOAP, it's a little different than REST, because with SOAP, they use XML, right, with envelopes and things like that. Really cool concept, but it's kind of getting outdated nowadays. I'm not sure. I'm not even sure how much is being used, but it is a tool that's used. Then you'd be executing the test cases and then automating the test execution. So you execute the test case and then you have to say, all right, let's trigger how we're going to execute these tests, and then you have to review the reports and analyze the results, and then you're going to integrate it with version control systems and try to see if you can get that running in a CI/CD pipeline as well. Next up, we have Rest Assured through Java, which it is a Java library, and this now there's no user interface for this, right? This is strictly through Java code. You'd be using an IDE, maybe IntelliJ or Eclipse or any other Java editor out there. But we're gonna be like, there's other ways to do this, but the easiest way, fastest way to get started, which we'll probably be doing on a live stream, is setting up the Maven project, and then you're gonna write your test cases saying, okay, this is the flow. Then you're going to configure your request and your assertion. So what's the request and what is the validation that we're going to be using? We're going to be executing our tests, analyze the test results, and then you set up your data, just like the other one, your data, so of what's going to be feeding into the API and what's the expected results. And then you're going to integrate it into the CI/CD process so that once you push up once the code gets pushed up, it can automatically trigger your API test so you can get immediate feedback. Similarly, using the request library with Python, you're going to install the request package, and I put a picture of like how it looks in Python to install the request library. You're going to be writing your test cases the same way with all the other tools. Configure your requests and your assertions, and you're going to execute your test cases, analyze the test results, data driven testing, and then the CI/CD integration, right? And they all are following the same exact process. It's just the tools that you use are just going to be different. The syntax that you're going to be using is going to be different. And those are the things that we're going to be looking at in the live stream. Like, how do we do it with Python? How do we do it with Java? How do we do it with Postman? And I've never even used I never used Postman to do automation testing, and I never used Newman to kick it off because I always jumped right into Python and into Rest Assured. And I'm sure in JavaScript, like with probably the chai libraries and things like that, that you can do the same things as well. So the next one is Karate DSL. It's a Java-based tool, but you're going to be pretty much setting up your project, running your test scenarios, analyzing test results, your assertions and your validations. You're passing in your data, reuse the common steps, and then integrate it in a CI/CD pipeline. I used Karate like maybe 6 or 7 years ago to try it out, and it was pretty cool. They didn't do too much in it, but it was pretty cool. And I'm seeing it's getting a lot more popular nowadays. So that's good to see that it is picking up, and it's based on the concept of Gherkin. So it's like Gherkins for API testing, or BDD for API testing. Right. So next up we have JMeter. So JMeter, we've actually had streams where we were using JMeter for performance testing and load testing and things like that. But you can also use it for API testing. And just to run down pretty much how to do it, API testing with JMeter, you're going to set up your project. You're going to add a thread group. You're going to add the HTTP request sampler, configure the request parameters, add assertions, configure test execution, run the test plan, view the test results. You're going to parameterize your test so that you can have many different variations of test data. That's pretty much like doing the data-driven part. And then you're going to integrate it into the CI/CD pipeline so that it can trigger off the JMeter test once it's there. Another cool thing about it is that you can also set it up to do your load testing as well, if needed, because it is important to make sure that your API test can handle the load as well. But that, you can strictly use JMeter for that, and then use other tools, or you can have everything running through JMeter. Lastly, we have Swagger. So Swagger is it's a tool that generates the documentation of your API, and it has a place where you can test out your API, right? So and I might actually do a live stream where, because I've used Swagger before, but I've never integrated into an API. So to generate the API documentation. So maybe I can do a live stream as well on how to how to set up Swagger into a project. But pretty much using Swagger, you're going to generate your test cases from the specifications of the API. You're going to write your test cases, and then you're going to do and then see, that's the thing. Swagger itself isn't used for API. It's used pretty much to set you up to do API testing. So you can use any of the previously mentioned frameworks to automate what the test cases generated from Swagger. But you're still going to use one of those other tools or any other API testing tool that you are comfortable with. But all the steps after that follow the same exact pattern. All right, so let's get into some best practices for API testing. So you want to design clear and concise test cases, right? And this should be for any test that you're writing. Should be definitely clear and concise test cases. Next up, you want to definitely, I can't stress this enough how important this is for API testing. You want to implement data-driven testing, because with the data-driven testing, you can have so many variations and so many you don't have that many expected outcomes, because there can be it's either going to be successful, maybe a redirect, or a 400, right? In the 400 range. But there can be different type of 400 that you want to validate for, whether it's authentication, whether it's for sending the right data. Maybe you're sending a get to a post and you're getting a 405. So there's so many different things, right? So you definitely want to do data driven, and then you have to do it for each endpoint as well, because let's say an application has 10 endpoints, and there can be 100 different variations of the data that's going in to those 10 endpoints. So you just need to make sure that any little change that happens in the API, you have to make sure that's working. And then you have to handle the authentication and the authorization, making sure that the right users, the requests that their users are making, they have permission to do it, and that their username and passwords are successfully being authenticated. You don't want to that any username and password that you send, or not sending any username and password, that's going to allow the API to make the proper calls. So that is something that you need to consider as well. So very important to make sure that your API tests are handling and testing the authentication and the authorization. Authentication, are you allowed to get in? Authorization, what are you allowed to do once you get in, right? So definitely want to keep that in mind when you're writing your test cases and when you're automating it. And then lastly, you want to make sure, or not lastly, but you want to make sure that you set up your test environments so that you can run locally, you can run on a particular branch of development, you can run in a development branch where all the main code is, and then if necessary, then you can run some tests, maybe not all tests in production where you're generating the data, but maybe getting your GET request. Those are coming from production to make sure that the API is working to some capacity in production, because guess what? Production is your most important environment. If production isn't working, the company is not working. And then lastly, incorporating assertions for validation. So you need to make sure, because it's one thing to make the API call, but you also need to make sure that the results that the API call is getting are the right results. So those are the biggest things to consider when automating API tests. And another best practice is integrating with version control systems, utilizing the continuous integration tools. So version control using GitHub or Bitbucket or GitLabs, whatever version control that you want to use. And then that is also connected with continuous integration tools. So when you push up this new code, this new branch, this new version, that it triggers off the continuous integration tools to run your API test, so that you can have immediate feedback and confidence that your code and your system is working correctly. So let's get into some case studies. We're going to look at Netflix, Salesforce, X, formerly Twitter, Shopify, and Uber. And by the way, do we still have to say formerly Twitter? How long do we have to say formerly Twitter until it's just X? I'm just asking. I'm just asking for a friend here. All right, so Netflix. Netflix, the popular streaming service, implemented API test automation to ensure the reliability and performance of its APIs across various devices and platforms. By automating API testing using tools like Postman and Rest Assured, Netflix improved test coverage, reducing testing time, and identified issues early in the development cycle. This allowed them to maintain a seamless user experience and deploy updates more frequently. And think about this. You might not be familiar with this, but the longer and further a bug goes, the more expensive it is to a company. So if you catch a bug before it even makes it to QA, right? Let's say the developers catch a bug during unit tests or during test-driven development. That saves the company a lot of money. Now, let's say it does get to QA and QA finds it. It costs the company a little bit more because now 2 people are involved, but it didn't get all the way to production where it can hurt. So now let's say you catch it. Let's say QA doesn't catch it. during like their development testing, but they get to like a staging server and oh, we found this, right? Now it's a little bit more expensive because the code is already merged. You have to unmerge the code, and then you have to fix it in that spot. And now, so it's taking a little bit more time and it's a little bit more tricky and things like that. So, so it starts to cost more. Now, let's say it gets to production and but a customer, it doesn't impact the customer, but you find it and then you fix it. Now we're going back some steps. Every time you have to go backwards, it's going to cost you. It's the same way people who are trying to transition after, 10, 15 years in a different career. And now they're like, they have to go backwards a lot of times in order to go forward. So, and sometimes people can't even afford it to do that, to go backwards. So those are like, so think about that, when you're talking about bugs and where bugs get to. So if it gets to production, but it hasn't impacted the customer yet, it still has to go back to development to get fixed. You might have to revert the release. Then QA has to test it again to make sure that it's working. And so that costs me more. But now the worst part, if it actually gets to production and it impacts the customer, now you can have unhappy customers, because if it's impacting one, it's probably impacting many. So now you have unhappy customers and you have to do some damage control. And it has to go back to the developers to fix it. It has to go back to QA to fix it. It has to go back through the testing pipeline, all the way back to the customer. And you don't know how much money and how much impact that have been costing you. And you don't even know how long, sometimes you don't even know how long it's been there, because it might be dormant for a while and then something happens, or especially if it's around a sale or something. So you definitely have to be careful with that. Next up, Salesforce. Salesforce is a leading customer relations management CRM platform. It adopted API test automation to streamline its development and release processes. By leveraging tools like SOAP UI and Selenium, Salesforce automated API testing for its cloud-based services, ensuring compatibility, reliability, and security. This enables faster releases, reduce regression errors, and enhance overall product quality, leading to API customer satisfaction. And guess what? Like at my previous company, I had used Salesforce API to facilitate some tests, to facilitate some migrations and things like that. So I was able to plug into their API, and like there is so much things that you can do with APIs. From like not it's like from testing it to facilitating tests, like staging test data, to doing migration work. So many things, right? So it's important to actually, like, for these companies to test their APIs, because they make their APIs public for users to integrate with and things like that. So it's not only to serve the front end, but it's also there to serve developers to integrate with their systems. Now, X.com. Twitter, the social media giant, so X, I should say X is a social media giant, implemented API testing, API test automation to validate the functionality and performance of its APIs, which powers its web and mobile applications. By using tools like JUnit, Apache JMeter, Twitter automated API testing to simulate real-world scenarios, handle large volumes of traffic, and detect performance bottlenecks. This helped Twitter deliver a more stable and responsive platform, enhancing user experience and driving user engagement. So think about Twitter. Like, how many messages come across Twitter or X on a daily basis? So they need to be, so I can see why they're using JMeter to also test the load of the application, because it needs to be able to handle that type of traffic, that type of volume. Like a few months ago, I remember like people couldn't post on X because either it was a software error or they couldn't handle the load. So and you have to think, like, with the load, you have to determine how much server disk space that you need, what type of latency, what kind of network connection, things like that. So all these tests, these API tests are super helpful. And APIs are used, like when you see, like, you can post to Twitter from some other application that's using the Twitter API. So they have to make sure that this stuff works. Shopify. Shopify is an e-commerce platform, adopted API test automation to ensure the reliability and scalability of APIs, which enables integration with third-party applications and services. By leveraging tools like Karate DSL and Postman, Shopify automated testing to verify data integrity, validate business logic, and detect regressions. This allows Shopify to accelerate development cycles, reduce manual effort. I'm going to read that again. Reduce manual effort and maintain high product quality. So imagine that, reducing manual effort and still maintaining or increasing product quality. leading to an increase in merchant satisfaction and business growth. At the end of the day, everything is about the customer and their satisfaction. So Shopify's customers are the people who place their stores on their platform. And then their customers are the ones who buy from them. So if there is an issue on the Shopify platform, it makes not only Shopify look bad, it also makes their customers look bad. And if their customers, through not selling bad products, but through a down platform, are getting bad user experience, then they're going to be looking to go elsewhere. And lastly, the case study of Uber. Uber, the ride sharing company, utilized API test automation to validate the functionality and performance of its APIs, which orchestrates various services and interactions within its ecosystem. By using tools like Rest Assured and Newman, Uber automated API testing to verify data consistency, ensure service reliability, and optimize response times. This enabled Uber to deliver a seamless and reliable experience to millions of users worldwide, driving customer loyalty and market competitiveness. All right, so while we talk about all the good stuff with API testing, API automated testing, what about some challenges for API automation? So there can be dynamic APIs, which can be quite troubling. And then like some APIs, there's complex scenarios, complex workflows. So you have to like chain API commands together. So maybe first you have to go and say, all right, if I do this request and now this request is going to need data from this request and going like that. So that can be a little bit complex. Is it impossible? Absolutely not. It's something to figure out. There's the test data management, because you can always be getting new test data, new scenarios and things like that. Trying to figure out the matrix of test data as well can be quite complicated. The maintenance of test scripts, that can be a challenge, but it's not that bad depending on how organized you are. So I'd say you need to make sure that your test scripts are very clean and they're maintainable. Because it's not only developers that should be refactoring their tests. QA should be refactoring their scripts as well to make sure that things are being done in the best way possible, the most efficient way possible. And then there are, of course, security concerns because you need to make sure that you are handling the test data correctly. One of the biggest mistakes people make is pushing security keys into their Git repositories, and then it's available for other people to see. So we just have to make sure that we are very secure. We're not putting any usernames and passwords and any valid credential, any customer data. We have to keep that private and secure. So those are some of those are like the basic API automation challenges. Of course, there can be more as we come across them, but those are like the top challenges that most people have. All right, so let's wrap it up, right? So in conclusion, we spoke about the manual testing challenges. We had our recap of the previous weeks. We spoke about manual testing challenges, the benefits of API automated testing, the tools and the frameworks that we use for API testing. And trust me, there's way more, but just going to cover those because those are the most popular. The best practices for API automated testing. We looked at some case studies and success stories of API automated testing. We spoke about the challenges, like some challenges you might run into for automating API testing. And now, if you have any questions or feedback or something that you think I missed, definitely go ahead and leave me a comment and I'll be sure to get back to you. And if something you want me to touch on, let me know and we'll make a video about it. And then we're going to be doing our API live stream on how to automate API testing tomorrow night, which is going to be Thursday. Right? On Thursday, we're going to be doing our API automation live stream. So how to get that set up, looking at different tools, right? Let's try to write a basic test. What we can probably do is use one of the APIs that we found, or maybe use Rapid API, something. We're going to figure out what we're going to do. And we're going to here's what we can try to do, right? We can try to create one test or maybe 4 tests, right? A post, a get, a put, and a patch. In a multitude of different tools and see how they work, how quickly it gets set it up, and we'll find out, right? But that's pretty much the plan. So let's go back to full screen so we can wrap this up, all right? So there you have it. That is our overview of automating API testing. So many different tools that you can use. And for the API testing, we might have to do 2 streams because there's a lot of tools and I would love to at least do some basic API automation on each of those tools so that I can I'm familiar with some of them that I'm not familiar with. And I can also show you that the ones that I am familiar with, how to get started, such as Python, such as Rest Assured, We can find out together how to do Newman. We can see some, like, we can probably, I don't know if I'm gonna actually go into SOAP UI. We'll see, right? We'll see. But I do want to try out Newman. I do want to use Postman. Definitely want to go into the Python request library. Definitely want to go into Rest Assured. I would love to try Karate as well. And then maybe even a third live stream where we can see if we can set up a Swagger doc for our API documentation. Very, very important stuff. And I would say if you are working for a company who is building APIs and you are a Q engineer, it is imperative that you talk about getting the right documentation and possibly setting up a Swagger doc or open API specification so that we can make our APIs usable to everyone. Okay, because when I say everyone, let's say it's not a public API, but for the people who are testing the API or interacting with the API within the company, it is super important that we have clean and clear documentation that we can just go into a place and that we can work through that, and we don't have to ask every other day or every other question of like, hey, what is this input? Hey, what are these requests? Or we have to decipher what those are through the code, which is it's very time consuming and not very helpful. So we definitely want to figure out how could help contribute to getting the API documented. Okay, so that is our topic for today. How to automate API testing, and we'll take it from there on the live stream tomorrow night, and maybe the next few live streams where we'll be exploring different API testing methodologies. All right. So with that being said, thank you guys so much for tuning in. Let me know if you found these last few weeks helpful talking about API testing, what it is, what APIs are, how to get started with API testing, and then how to automate API testing. But yeah, we're gonna wrap it up. If you haven't done so already, do me a big favor: like the video, share the video, subscribe to the channel, hit the notification bell so you can know every time that we go live. Leave me a comment because I would love to hear your thoughts, your feedback, everything like that. And if you are in need of one-on-one coaching, go over to www.techcoachralph.dev where you can sign up for a coaching plan today, as well as get access to exclusive content that I make available to you to help you level up your career. But on that note, I'm going to head out. Until next time, see you guys tomorrow night on the live stream. This is Tech Coach Ralph, and we are out.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.